So yeah, okay. Guys, my screen is visible, right, everyone? Okay. So good evening, everyone. Hope everyone is doing good. Good evening, Shubham, Sneha, Naresh, Rocky. Great. So guys, today is our last session and today we will take a problem statement and what we will do is like first we will go to the brute force solution and after that we will see like how to optimize that solution, what is the power of observation here, okay? And like what is why time complexity play a vital role, okay? In order to optimize the solution, okay? So these things we will discuss in today's session. Apart from that, till today in the 5 day essentials, whatever we have learned till now, okay, whatever we have learned till now, we will apply each and everything in this problem solving session, okay? So yeah, so give me 1 minute here. Okay, good evening all. So basically, let me see the, okay, okay, great. So good evening everyone. So let's start our session now. Okay. So good evening all. Good evening all. So let's take our problem statements. Yeah. Let me share my screen now. Yeah. So here we will take a simple problem statement. First we will go to the brute force solution, and after that we will try to optimize the solution. Okay. We will see how observation and how what is the role of time complexity here. Okay. So yeah. So let's start our session. So the program is simple here. What we have to do, write a program to check if a number, if a given number is a prime number or not. Okay. If a given number is a prime number or not. Okay. So this is a simple program here, guys. So what we have to do, we have to check, right? We have to check whether the number is a prime number or not. So guys, can you write in the comment what is the prime number, everyone? Okay. What is the prime number, guys? Please write in the chat. Okay. Anyone? Okay. I'm waiting for the answer, guys. So no one? Okay. So guys, yeah. So here, what is prime number, guys? Hello everyone. Can you please write in the chat what is the prime number? So great, Rocky. Rocky has written number divisible by one and itself. Okay, number divisible by one and itself. So one person here is saying ki, hey, prime number is what? Number that is divisible by one and itself, right? Okay, I want the definition, Mohammed. Yeah, a number divisible by, so everyone is saying number divisible by one and itself. Number divisible by one and itself. Okay, yeah. So guys, if you are saying ki, hey, this is a definition of a prime number. This is a definition of prime number. So according to you, 2 is a prime number because the factors of 2 is what? 1 and itself. Okay. 3 is also a prime number, right? 3 is also a prime number according to you, right? Because 3, that is the number that are divisible 3 are what? 1 and 3 itself, right? Similarly, 5, 7, 11 are prime number according to this definition, right? But can you tell me this definition is valid if I am taking the number as 1 here? Anyone? Please write in the chat. 1 is a prime number or not? 1 is a prime number or not, guys? If your definition are correct here, then 1 is a prime number or not? Okay, Abhijit is correct here. He is saying ki, hey, 2, 3, 5, 7 But what about 1? No. So according to you, the definition is wrong here then, right? Everyone? You are saying here 1 is also what? Divisible by 1 and itself. So why 1 is not a prime number? Everyone. Okay. So yeah. So guys, like you are partially correct here. So the actual definition of prime number is what? Prime numbers are numbers that have exactly two unique factors. One is natural number, right? One is natural number, but the definition of prime number is what? Prime numbers are numbers that have exactly two unique factor, right? Unique factors, and these factor can be one and itself. And these factor can be one and itself. Okay, factors can be one and itself. Everyone is clear with the definition part? So first I have given a problem statement. So first I should be clear in my mind what is a prime number. So now according to this definition, 1 is not a prime number, right? Because it has only one unique factor. Okay, the factor of 1 is what? 1. So that's why it has not two unique factors. So that's why we are saying that 1 is not a prime number, right, everyone? So now our definition is clear, and now our intuition is also clear, right, everyone? Hey, in order to check whether the number is prime number or not, I have to count factors, right? I have to count factors here. So yeah, we have to count factors here. So guys, can you tell me now? Yeah. So guys, can you tell me now from where to where I have to check, like I have to count factor from which point to which point? And if I have to check for 24, okay, if I have to check whether when the value of n is 24 here, and I have to check whether this number is a prime number or not, I'm saying hey, I have to count factors. So guys, can you tell me what will be the starting point and what will be the end point here? From which range, from which point to which point I have to count the factors? Anyone? Please write in the chat. Okay. So from 2 to 24, right? From 2 to 24, you are saying hey, I have to check, right? So basically, you are saying, okay, from 2 to 24 or from 1 to 24? 1 is also a factor of 24, right, everyone? 1 is also a factor of 24. So why you are saying 2? Right. No, no, no. I have to count, like first I have to check whether the number is a prime number or not. Then I saw the definition key. Prime number have exactly two unique factors, and these factors can be one in itself. So now my intuition is what? I have to count factors of a prime number. So guys, I have to start from 1, right? Because 1 is also a factor of 24, right? 1 is also a factor of 24. And here I'm saying, hey, first I will count factors, and after that I will write a check condition here. If count is equal to 2, that means the number is a prime number, okay? Else the number is not a prime number. So this part I can achieve with the help of if else statement, right? If else statement, I can achieve this part because I have to take a decision here. I have to take a decision, so that's why I will use if else here. So now the main problem is what? This problem. That is, I have to count factors of a number, right? I have to count factors of a number. So I'm saying ki, hey, I have to start from 1, not from 2. I have to start from 1 because 1 is also a factor of 24, and I have to go till 24, right? I have to go till 24. So now I know the starting point. Now I know the end point. I have to use a for loop. The basic for loop I have to use here. So what I will write here ki hey, yeah. So I will start from for int I is equal to 1, right? Int I is equal to 1. I is less than equal to n, I plus plus, right? And here I will take one variable to store the answer, right? And I will initialize that variable with 0. Simple, right? After that, inside the for loop, what I will do? I will write a check condition ki hey, if the number is divisible by, if the value of I is divisible by 24 or not. And how I can check that part? Okay, how I can check that part, guys? With the help of a modulo operator, because modulo give me the remainder. So Kalin Kazmi, it is like the it is like the English session, this boot camp. So we have to continue with the English part because there are audience from various part of the country. Okay, so sorry for that. But here I'm using simple English, so I hope you will get the understanding. Okay. सो इफ यू आर नॉट गेटिंग इट, सो फॉर द हिंदी ऑडियंस आई एम सेइंग कि है यहाँ पर हम लोग को एक फॉर लूप यूज करना है एंड फॉर लूप यूज करने के लिए व्हाट आई वांट द स्टार्टिंग पॉइंट और एंड आई वांट द एंड पॉइंट. ओके, और ये स्टार्टिंग पॉइंट और एंड पॉइंट कैसे पता चलेगा? फ्रॉम हियर हमें काउंट फैक्टर्स करने थे, तो हम बोल रहे हैं कि वी विल स्टार्ट फ्रॉम i इज इक्वल टू 1 एंड वी विल गो टिल i लेस देन इक्वल टू 24. ओके, so after that I know if in order to check whether I is a factor of n or not, I have to use a modulo operator because modulo give me the remainder here, right? So here I will write the condition ki hey, if n modulo I is equal to 0. Okay, if I is divisible by n, if I is divisible by n, what I will do, I will increase the count. I will say ki hey, I found one factor. I found one factor of n. Everyone is clear? After that, here what I will do, I will write a check. Here I am done with the part. This for loop will start from 1 and it will go till n and it will calculate count. It will calculate count of factor here. Okay, so here we are checking I is divisible by n or not, right? I is divisible by n or not, and if it is divisible, what I'm doing, I'm counting factor here, right? Counting factor here, I'm increasing the count by 1, and after that here I have to write the condition because according to the definition I know ki if the count is equal to 2, that means I found two unique factors, right everyone? I found two unique factor. So here what I will write, if count is equal to 2, what I will do here, I will say ki yes, the number is a prime number, right? System.out.println and here prime number, right everyone? Simple program here. Okay, let's try to do some observation on that this program and then you will get the clear idea ki why I am taking this example here. Okay, so 1 minute here, let me complete this program. Okay, so here else part, and in the else part you will write system.out.println not a prime number. Okay, not a prime number. Simple intuition we have used. We have to check whether the number is a prime number or not. According to the definition here, in the definition itself it is written ki hey, in order to check whether the number is a prime number or not, I have to find how many factors this n have. If this n have two unique factors, that means the number is a prime number. So for that thing I'm using one loop that is starting from 1 till n, and I am counting the total factor between 1 and n. After that, here I have written a simple if condition where I am checking whether count is equal to 2. So according to the definition, this is a prime number, else this is not a prime number. Okay everyone, so let's make one observation here. Okay, let's assume ki hey, can you guys tell me how many times this for loop will execute? Everyone, how many times this for loop will execute? Please write in the chat. Yeah. Rocky, I will go to this part also, but can you please answer everyone how many times this for loop will execute? The body of the for loop will iterate how many times, execute how many times? Okay, anyone? The body of the for loop iterates, correct. Kuldeep is correct here, and Rocky is also correct here. He is taking the value of 24. But here you can see ki the value is n. The last point is n. I am starting from 1 and I am incrementing my I by 1. So this means this body of the for loop will execute n times, right? So this execution, the body of the for loop is executing n times. So I am saying ki hey, number of iteration of my code, number of iteration of this for loop is what? N here. Okay, let's make one observation here now. I have a computer and the efficiency of the computer is what? It execute let's suppose it execute 10 to the power 8 iteration. It execute 10 to the power 8 iteration in 1 second. Okay, I have a computer and the efficiency of the computer is to execute 10 to the power 8 iterations in 1 second. So I can write like this: in 1 second, my computer is executing 10 to the power 8 iterations. Okay, everyone. After that, I'm saying ki, hey, yeah, okay. After that, here I'm saying ki, hey, my for loop is doing how many iterations? It is doing n number of iterations. You guys have told me in the chat ki, yes, my for loop is doing n number of iterations, and here I have taken one computer where I'm saying ki, hey, my computer is doing 10 to the power 8 iterations in 1 second. So if the value of n is 10 to the power 9, if the value of n is 10 to the power 9, then can you guys tell me in the chat how much time my computer will take to execute this code? Everyone, how much time my computer will take to execute the whole code, to execute this for loop? Everyone in the chat, the question is clear, right? Should I explain the question again or it is clear? Okay, more than 1 second, like approx exactly how many seconds? So here I am saying ki, hey, 1 second is equal to 10 to the power 8 iteration my computer is doing. So if I have to check whether 10 to the power 9 is a prime number or not, if I have to check whether 10 to the power 9 is a prime number or not, then I'm saying ki, hey, again, my program will take n iterations. My program will take n iterations. So that means ki one iteration is equal to 1 divided by 10 to the power 8 second. Okay, one iterations is equal to 1 divided by 10 to the power 8 second. So 10 to the power 9 iterations is equal to 10 to the power 9 iterations is equal to 10 to the power 9 divided by 10 to the power 8 second. Right, everyone? I can write this line, right, everyone? Simple math. So here you are saying ki, hey, everyone is correct now. Okay, like Rocky is correct here, and yeah, not 1.08 second, it is 10 to the 10 second, right, everyone? It is 10 second. So you have made a simple observation. You are saying ki, hey, I have a computer and the efficiency of the computer is what? It is doing 10 to the power 8 iteration execution in 1 second, right? So according to this specification, according to this efficiency, if you are saying ki, hey, if I have to check whether this 10 to the power 9 is a prime number or not, then how many seconds my computer will take? It will take 10 seconds, right, everyone? Let's take another value of n. Let's say ki, hey, okay, this is here, and now I'm saying ki, hey, the value of n is 10 to the power 18. The value of n is 10 to the power 18. Again, I will use the same formula. One iteration is equal to 1 divided by 10 to the power 8 seconds. Okay, one iteration is equal to 1 divided by 10 to the power 8 seconds, and I have to check whether 10 to the power 18 is a prime number or not, right? Because in the IT field we have to deal with the humongous amount of data, right? And the value of n can be as large as possible, right? So here I'm checking ki whether 10 to the power 18 is a prime number or not, and I'm saying ki, hey, I have written a program here that is doing n iterations. So in order to check whether 10 to the power 18 is a prime number or not, it is doing 10 to the power 18 iterations, right? So here I will write 10 to the power 18 will do 10 to the power 18 divided by 10 to the power 8 second. That means my program will take 10 to the power 10 second to check whether the number is a prime number or not. Everyone is clear till this point? If yes, can you guys tell me how much time this is? This is 1 week, 1 day, 2 hours, 5 hours in the comment. Everyone. Okay, I'm waiting for the answer. Kuldeep, Rocky, everyone, Shivam, Cypher, Vinod, everyone, yeah. I'm waiting for the answer. How much time this is? 10 to the power 10 second. It is like approximately you can tell me. Approximately you can tell me that like 1 week, approximately 1 year, 1 day. Everyone? Okay. So guys, this is approximately equal to 300, 317 here. 317 here. Okay, everyone. So here you are saying ki, hey, this is a simple program I have written, right? This is a simple program I have written, and this 10 to the power 18 is a prime number or not. I have written a program, and this program is taking 317 years. And guys, you will be not alive here, right? You will be not there to see whether the number is a prime number or not, right? If you have written this program, and if the value of n is 10 to the power 18, right? So here comes the need of time complexity. Here comes the need of observation. Okay, so now let's try to observe some point related to the program that I have written. Okay, and after that let's try to optimize the solution and then again see the time complexity. Okay, so yeah, everyone is correct now. Yeah, correct. So approximately 317 years, right? So here, guys, the main focus is what? Why this time is increasing? Why this time is increasing? If you will focus carefully, the time is increasing because of the number of iterations. The time is increasing because of the number of iterations, and the number of iterations is dependent on this for loop. Because of this for loop, my number of iterations are what? N. Okay, and someone is saying ki, hey, I can do this program in n by 2 also. So if suppose you are doing this program in n by 2, then also the number of iterations will be n by 2, and this value, that is 317 here, will be like approximately equal to 300 something here. Okay, so then also you have to take 300 here to check whether the number is a prime number or not. Okay, everyone. So I am saying ki the number of like the time is dependent on number of iterations, and number of iteration is dependent on this for loop. So basically I have to optimize something in this for loop. I have to optimize the logic inside the for loop. Okay, and basically the next question is what I am doing in this, in the body of the for loop. What I am doing, I am just checking, I am just calculating the count of factors between 1 to 24. Basically the observation is what here, I am counting the number of factors in a for loop. That's why I am going from 1 till n. Okay, so let's see one expression here. Okay, so here you are saying ki, hey, number of iterations. Okay, time is dependent on number of iterations. Number of iterations is dependent on for loop, and inside the for loop, your intuition is what? Your intuition is what here? You are calculating the count of all factors of n. Okay, so we reach to this point. Our observation is saying ki you reach to this point, and because of this point, your time complexity is increasing. So what you have to do now, you have to think how to optimize this point. Let's see now. So guys, can you tell me if I will write one line here ki, hey, a into b is equal to n. If this is my expression and I am saying ki, hey, I know, let's suppose the value of n is 24 here. Let's suppose the value of n is 24 here, and I am saying ki, hey, I know one factor of n. That is, let's suppose the factor is 4 here. I know the value of a. I know one factor of n, that is 4 here. Can you guys tell me if I will use this expression here, if I will use this equation here, I can find the next factor, right everyone? I can find this next factor, that is 24 divided by 4. Okay, I will get 6. Okay, again, if I am saying ki, hey, I know ki a is equal to 2, that is 2 is a factor of 24. 2 is a factor of 24. At the same time, I can find the next factor also, right? At the same time, I can say ki, hey, 12 is also a factor of 24. 12 is also a factor of 24. Again, let's take one example. Again, if you guys are getting it, please write in the comment yes. I am saying ki, hey, a is equal to 1. I am saying ki the 1 is a factor of 24. So at the same time, I can say ki 24 is also a factor of 24, right everyone? So what I am saying here, ki when I am calculating the count of factor, here what I am doing, I am saying ki like At each iteration, I am calculating one factor. At each iterations, I am calculating one factor, but according to this equation, we observe कि if I know one factor of n, I can easily calculate the next factor. If I know कि 2 is a factor of 24, then I can easily calculate कि yes, 12 is also a factor of 24. Okay. Sir, can you please explain again this logic? Okay. So here, basically, I am saying that my time is dependent on number of iterations and my number of iterations is dependent on this for loop, and this for loop, like why I am going from 1 till n, because I have to calculate the count of all factors of n, because I am saying that hey, if the value of count is equal to 2, that means the number is a prime number, else the number is not a prime number. So I have to optimize this part. I have to optimize this logic part. So in order to optimize this logic part, I have written one equation here. That is, if I will say ki hey, basically factor is what? The number is divisible by n, then the number is a factor of n, right? So here if I am saying ki hey, 2 into 12 is equal to 24. 2 into 12 is equal to 24. So I am saying ki 2 and 12 are factors of 24. This part is correct. 2 and 12 are factors of 24. So I am saying ki hey, if you know the value of a, that is if you know ki 4 is a factor of 24, this 4 is a factor of 24. So guys, can you find the next factor? Can you find the value of b, right? Yes, I can find the value of b, that is n divided by a. That is n divided by a. That is 24 divided by 4. That is 6 here. Okay. So I am saying ki hey, if I know one factor, I can easily calculate the next factor. Okay, Rocky and everyone. So here, this is my observation. This is my first observation. Okay. So here you are saying ki hey, let's try to make a table here. If you are saying ki my value of I is what? In this for loop, what I am doing here, let's copy this for loop here. So this is my for loop and our intuition is what here? I am first what I am doing, I am saying ki hey, the value of I is equal to 1. Yes, 1 is a factor of 24 and the value of n is 24 here. Okay, the value of n is 24 here. This is the value of n here. Okay, yeah, this is the value of n, and here I am saying ki hey, first what will happen, the value of I is equal to 1, 1 is less than equal to 24, the condition is true. I will check whether the number is divisible by n or not, whether the value of I is a factor of n or not. Yes, 1 is a factor of n. Again my for loop will iterate. The value of I is what? 2. 2 is also a factor of n, that is 2 is also a factor of 24. The value of count will increment by 2, right? Here the value of count is what, guys? Here the value of count is 1, right? And after that the value of count will be incremented by 1, that is 2. Okay, after that you are saying ki hey, I is equal to 3. Yes, 3 is also a factor of 24. So this if condition will become true, and that's why the value of count will increment by 1, right? So this 3. Okay, again you are saying ki 4 is a factor of 24. The value of count will be incremented by 1, that is 4 here. Okay, after that you are saying ki hey, 5 is not a factor of 24, so this if condition will become false. I will not increase count. 6 is yes a factor of 24, right? 6 is a factor of 24, so I will increment my count by 1, that is 5 now, right? After that what I will do, 7 is not a factor of 24, so this if condition will be not true, right? So the value of count will not be incremented. After that 8, yes, 8 is a factor of 24, so the value of count will be incremented by 1, right? Okay, please observe this part. Okay, what I am doing inside the for loop, what we are doing inside the for loop, please observe this part. That's why I'm dry running from 1 till 24. After that 9, 10, 11, 12. 12 is a factor of 24. Similarly, the next factor will be what, guys? 8, no, 12. After that what? 24, right? Yeah, after that 24. Okay, I'm missing any factor here. So here the value of count is 7. Please write in the comment if I'm missing any factor here. Okay. The value of count is what? 8 here. Okay. So 1, 2, 3, 4, 6, 8, 12, 24. And after that the value of I will become 25, and this if condition will become false, and I will move out of the for loop. So basically, because of this calculation, I am doing n number of iterations. But I have made one observation here. I have made one observation here. This observation, this one, right? Yeah, this observation. I have made one observation ki if I know one factor of n, then I can easily calculate the next factor, right? So here I am saying ki hey, yeah, let's remove this point from now. Okay. So till this point, I am hoping ki everyone is clear, right? Yeah, it is clear, right? So I have made one observation here. Let's write the observation also ki if I, okay, let's write ki if A into B is equal to n, right? If I know one factor, then with the help of this equation, I can find the next factor. This is a basic math we know. Okay. So basically, when the value of I is 1, and I am saying ki this is my factor, this is a factor of 24. Okay. Then at this time, I can calculate the next factor also. By how? By saying ki n divided by I. By saying ki n divided by I, right? So 1 is a factor of 24. So the next factor will be what? 24. 24 divided by 1 is 24, right everyone? Similarly, 2 is a factor of 24. So at that time I can say ki 12 is also a factor of 24, right? 24 divided by 2 is 12, right? Similarly, 3 is a factor of 24. So at that time I can say ki hey, 8 is also a factor of 24. Similarly, 4 is a factor of 24. At that time I can say ki hey, 6 is also a factor of 24. 6 is a factor of 24. So at that time I can say ki hey, 4 is also a factor of 24. Similarly for 8, 3 is also a factor of 24. Similarly for 12, 2 is also a factor of 24. And similarly for 24, 1 is also a factor of 24. This I can achieve by this equation. A into B is equal to n. So guys, this is a table you are getting. After making this observation and after concluding ki yes, at the same point, if I know one factor, I can easily get the next factor by doing n divided by I, right? So here you have made one table, and guys, can you tell me basically our aim is what? Our aim is what? We are calculating all the factor of n, and that's why we are going from 1 till n. But here guys, can you tell me at which point our factors are repeating? At what point my factors are repeating? Anyone? Can you guys tell me in the comment at what point my factors are repeating in this table? Okay, you can see this table, right? You can make some observation. My factors are repeating at a particular point. After a particular point, my factors are not unique, they are repeating. And according to the definition of prime number, it is saying hey, you have to calculate all the unique factor, and if the value of unique factor is 2, the count is 2, then it is a prime number. Middle of the table, no, it is not the correct observation here. You are close to the observation. Okay, any other observation you can make? 4 and 6. Okay, yeah. So you are saying hey, after this point my factors are repeating. Till this point is clear. So can you guys tell me with the help of an equation how you can say to the computer ki yes, after this point your factors are repeating? How you can like tell to the computer this part? So here you are saying ki hey, when the value of I is less than equal to, okay, sorry, yeah, when the value of I is less than equal to n divided by I, okay, at this point, like after this point, when the value of I will be greater than n by I, after this point my factors are repeating. So that's why I have written this line here. Okay, I have written this line here ki hey, when my first factor becomes greater than the second factor. Here you can see ki my first factor is smaller, second factor, like all the factors, the first factor are smaller than the second factor. The moment my first factor will become greater than the second factor, then I am getting the repetition of common factor, right? So on that basis, you are saying ki, hey, my first factor is what? I. My second factor is what? N divided by I. So I can write this line. Okay, I can write this line, right, everyone? Ki, hey, till this point, till the value of I is less than equal to N by I. Till this point, I will get unique factor. Okay, I will get unique factor. Okay, and after this point I will get repetition of factor, right, everyone? So what I can write here, I can write like this ki, hey, I into I is less than equal to N. What I have done, I have taken the denominator and I have put the denominator to the left hand side part, and when we are switching the denominator from the right hand side part to the left hand side part, we have to multiply, right? Because here we have a division. This is a simple math, everyone knows. So I can write like this, I into I is less than equal to N. Everyone is clear? Please write in the comment yes or no, this point is clear. So I can write like this, I is less than equal to square root of N. Yes or no? Yes or no, guys? Please write in the chat. This part is clear. I am writing ki, hey, I is less than equal to N by I. Till this point I am getting unique factor. Okay, when the value of I is greater than N by I am getting common factor. So I will not include these factors. I will not include this factor. And another point you can observe ki, hey, if you are getting all the factors till this point, if you are getting all the factors till this point, then why you are going till 24? Okay, why you are doing extra iterations? And because of these extra iterations, your time complexity is increasing. Okay, the time taken by the computer is increasing. So you don't have to go till 24. You don't have to go till N. You have to stop at this point. And if you are stopping at this point, you are saying ki, hey, I am able to find all the unique factor. Okay. So here I am writing here I into I. If I will write like this, ki 2 into 2, right? 2 into 2 is equal to 4. Okay. This part is clear, right? 4. So if I will take the square root of 4, then what I will get, guys? Simple square root. I will get 2 again, right? Square root everyone knows. Okay. Square root everyone knows. So this part I am writing here. Ki I into I is less than equal to N. So I is less than equal to square root of N. Yes or no, Rocky? It is clear? If I will say ki, hey, 3 into 3 is equal to 9. So I can write like this, ki square root of 9 is what? Square root of 9 is what? It is 3. Okay. If you know square root, it is good. If you are not have knowledge of square root, you can search on the net and you can say ki, hey, if I don't know this condition, I will use this condition. Okay. Both the condition are same. Both the condition are same here. Okay. Here I am saying I into I is less than equal to N, and here I am writing I is less than equal to square root of N, right? So I got the stopping point. Okay, I am saying ki, hey, I don't have to go till N. I have to stop at this point, and this point is what? I into I is less than equal to N, or I is less than equal to square root of N. Both the equations are correct. So now what I have to do? I know the starting point, I know the end point, and I know at a particular point. At a particular point, I know the starting point is what, guys? The starting point is 1, and the end point is I into I is less than equal to N, right? And there is no need to go below this point, below this horizontal line. And you are saying ki, hey, at a particular point, if I know ki this one is a factor of 24, then at the same time I can find the next factor. Okay, and basically our aim is what? I have to count all the factors. Okay, I have to count all the factors. So again, let's try to write the code with the help of this observation. Okay, this is my previous code. This is my previous code here. Let's write the previous code here. And you are saying now ki, hey, this time you don't have to go till N. In order to calculate, in order to count all the factors of N, you don't have to go till N. You can write like this. I into I is less than equal to N. I into I is less than equal to N. Right, everyone? I can write this line because our main aim is what? Why we have written this for loop? we have written this for loop in order to calculate all the unique factor. Okay, so I'm saying ki hey, there is no need to go after this point. After this point, there is no need to go because till this point you will get all the unique factor by this expression, that is a into b is equal to n. Okay, so let's do some changes here. So here you are saying ki hey, now if I get the one factor, if I am saying ki hey, I is divisible by n, if I am saying ki hey, 1 is a factor of 24, then at the particular moment I can say ki I can get the next factor, that is 24. So why I am incrementing my count by 1? Why I am incrementing my count by 1? Okay, there is no need to increment your count by 1. You will say ki hey, I will increment my count by 2. Everyone is clear? Why I have incremented the count by 2? Because you are saying ki, hey, if the value of I is equal to 1, let's take one example, I is equal to 1, and you are saying ki my if condition will become true, this if condition will become true, and you are saying ki, hey, if I know one factor, then 24 is also a factor, so I will increment by 2. Everyone is clear? Count is equal to 2 now. Again, I is equal to 2. You are saying ki and modulo 2 is equal to 0. Yes, 24 modulo 2 is equal to 0. So at this point also I am getting 2 factor. Okay, I am getting 2 factor, that is count plus 2, that is 4 here now. Everyone is getting it now, right? So there is no need to write the other factor also. You are saying ki, hey, I know this point. So why to write this condition? I can directly increase my count by 2. Everyone is clear? So here is your first takeaway ki if you just go from 1 to square root of n. Okay, the first takeaway is what? If you just go from 1 to square root of n, okay, you can get each and every factor. You can get each and every factor. This is your first takeaway from the observation, each and every factor. Okay, so there is one loophole in this program. I will come to this point, but you are saying ki, hey, if I have to count all the factors of a number, then also I will use this program. Okay, if I have to count the factors of all the number, then also I will use this program, and if I have to check whether the number is prime or not, then also I will use this for loop, because this is the optimized version of my brute force solution, right? After that, here again you will write the same condition, this one, right? The condition will be same. If the value of count is equal to 2, the number is a prime number, else the number is not a prime number, right? So here you have written the if condition again. Everyone is clear till this point, guys? Okay, so there is a one loophole. Please try to observe this loophole. Okay, here I have done one mistake. Okay, let's try to see what mistake I have done. So here you are saying ki, hey, if I know one factor, then I am able to get the next factor, and you are calculating what? You are calculating all the unique factor. So let's take one more example here. Let's take one more example here. If the value of n is 36, if the value of n is 36, can you guys tell me how many factors, what will be the value of count here for the value of n is equal to 36? Everyone in the answer, everyone in the comment, please write. What will be the value of count here when the value of n is equal to 36? Okay. How many factors you will get when the value of n is 36? Okay. So, okay, please write in the chat 4, 5, 6 factor, 7 factor, 10 factor. Anyone? Okay. So basically, guys, yeah. So here, anyone? No one? No. Yeah. Okay. So guys, here the value of n is 36. You are saying ki here 1 is a factor of 36. Basically, the value of I is 1. So 1 is a factor of 36. So the next factor is 36, right, everyone? So here the value of count will be incremented by. So great, Roshan. He has answered the question. It is great. You have tried. answering this one, that is 9. Okay, so let's see now. So here, according to our question, what I'm doing, according to our problem, like according to our logic, what I'm doing, I'm increasing the count by 2. So it is correct, I will increase count by 2, right everyone? After that, 2 is also a factor of 36. So the next factor is 18. So again, I am increasing the count by 2. That is 4. Right, everyone? After that, 3 is also a factor of 36. So I will take it 12 is the next factor. So what I will do? Increase the count by 2. That is 6. Right, everyone? After that, you are saying ki, hey, 4 is a factor of 36. So 9 is my next factor. So that's why I am increasing the count by 2 again. So here count is what? 8. Okay. But when the value of I is 6, when my one factor is 6, then at this time I am getting the same factor, that is 6. So what I have to do here? I have to increase count by 1. But here what I have done? I have increased the count by 2. So according to our logic, what I'm doing here, I am saying ki hey, total number of factors are 10. So it is calculating the same factor also. So here I have to write a check ki hey, first you have to increment by 1, and what you have to do here, again you have to write a check, that is if if my one factor is not equal to the next factor, if my one factor is not equal to my next factor, so at this time what I will do, I will again increase count by 1. Okay, so this condition, why I have written I not equal to n by I, so to handle this test case, to handle this situation, so I have written this point. Everyone is clear now कि why I have written this if part, that is I not equal to n by I. I am saying कि hey, if both the factors are unique, then I will again increase count. If the both the factors are common, then this if condition will not get true, and this mean I will increase the count by 1. Everyone is clear, right? So let's try to make a observation now on this code, and again I will take the same system. Again I will take the same system, and yeah. So yeah. So again, I have the same computer, same efficiency, okay? And this time you are saying ki, hey, the number of iterations are what? It is equal to square root of n. The number of iterations are what, guys? It is equal to square root of n. So this time you have written a optimized code, and you are saying ki the number of iterations, okay, the number of iterations are what? Square root of n, okay? Square root of n. Okay, yeah, correct. So number of iterations are square root of n, and you are saying ki, hey, again I have the same computer, same efficiency, that is I have a system where my system is doing 10 to the power 8 iteration in 1 second. It is executing 10 to the power 8 iteration in 1 second, right everyone? So you are saying ki, hey, one iteration will be equal to 1 divided by 10 to the power 8 second. So if I have to check whether this 10 to the power 9 is a prime number or not, and you are saying ki, hey, now my number of iterations are what? Square root of square root of n, right? According to this for loop. According to this for loop, you are saying ki, hey, my number of iterations are what? Square root of n, and you are saying ki, hey, my system is having this configuration, okay, this efficiency. So if the value of n is equal to 10 to the power 9, and I have to check whether the number is a prime number or not, then I am saying ki my for loop will do square root of n iteration. So square root of 10 to the power 9. Square root of 10 to the power 9 is equal to what, guys? Anyone? It is approximately equal to 10 to the power 5. I am saying it is approximately equal to 10 to the power 5. How you got? You can write like this: 9 divided by 2, 10 to the power 9 divided by 2, and it will give you 10 to the power 4.5. And I am saying, hey, let's take 10 to the power 5 now. Okay, 10 to the power 5. So basically you are saying, hey, 10 to the power 5 iterations my program is doing to check whether 10 to the power 9 is a prime number or not. And here you are saying, hey, if I like my program is doing 10 to the power 5 iterations here, then how many seconds it will take? It will take 10 to the power 5 divided by 10 to the power 8 seconds, right everyone? Anyone has any doubt in this part? So how much time my program will take? It will take equal to 0.001 second. Okay, so previously when I have written the brute force solution, then how much time my program is taking? It is taking 10 seconds to check whether 10 to the power 9 is a prime number or not. Right, everyone? And now when you have optimized your code on the basis of some observation, you are saying ki, hey, it will take 0.001 second. Roshan, it is 0.001, right? This is the best case we are discussing. And we are like we have observed, we are concluding from this observation कि previously when we are going till n number of iterations, then we are taking 10 seconds to check whether 10 to the power 9 is a prime number or not. And now we are saying कि hey, now my for loop is doing square root of n number of iterations. So this 10 to the power 9 will become 10 to the power 5 iterations, and if I will put the value in the equation, then I will get 0.001 second. So you have optimized the time from 10 second to 0.001 second. This is your first point. Let's take the value of n is equal to 10 to the power 18. Okay, let's see whether this number is a prime number or not. And yes, if it is, then how much time my optimized code will take. Okay, again, you are saying कि hey, number of iterations are what? Square root of n, square root of, yeah, I'm going to this point only, right? Here you are saying, hey, according to your optimized code, it is saying कि your program, your for loop is taking square root of n, and the value of n is what? 10 to the power 18 here. Okay, and here you will say कि hey, 10 to the power 18 square root is what? 10 to the power 18 divided by 2, right? And it is equal to 10 to the power 9. 10 to the power 9. Okay, so here you have 10 to the power 9 iterations, right? Here you have 10 to the power 9 iterations, right? So you are saying ki, hey, I know one iteration is equal to 1 divided by 10 to the power 8 second. 10 to the power 8 second. Then 10 to the power 9 iterations will be equal to how many seconds? 10 to the power 9 divided by 10 to the power 8 second. This will be equal to 10 second. So previously, when you have written a brute force solution, right, everyone? When you have written the brute force solution, and for the brute force solution, when you are checking for this value, that is 10 to the power 18. So for this value, your time is what? 317 years. And after doing some observation, after improving your code, after reducing the number of iterations, okay, okay, you have reduced the time from 317 years to 10 seconds, right, everyone? You have improved the time from 317 years to 10 seconds, and this is a huge optimization you have done. Okay, so this is a power of observation. This is a power of like thinking in the right direction. This is a power of time complexity. Okay, that's why, like, you know how to write a brute force solution, but that's why optimization is important. Okay, everyone, so this class is for the problem solving session, and like I don't have enough time. Like it is already 8:56, and there are a lot to discuss, but we cannot discuss in this 1 hour. Okay, but hope I'm able to give you a gist of a time complexity, power of a observation, right, everyone? Yes or no? So basically, there are a lot of things that are dependent on number. Like now you got the number of iterations, okay, and you are saying here 317 seconds. But there are some like you can say climax are still there, right? Where you have to calculate the time complexity in big O of n. And what is this big O of n? What is this asymptotic analysis? Yes, but I will tell you, like I have a few minutes, right? Yeah. So I will tell you ki when I am doing analysis on the basis of a large data set, when I am doing analysis on the basis of large data set, then this analysis is called asymptotic analysis. Okay, asymptotic analysis. and after that I need time, okay, and like we have less time here. So guys, this is all for the today's session. Hope you are able to get most of the concept. Sir, time complexity is important in interview coding. Yeah, it is very important. Rocky, if you will go to the fan company, any Google, Facebook, they will not ask about the approach. Okay, they will ask you about how to use which data structure. Okay, how to optimize the space complexity, what approach, like why you are thinking to take this variable, why you are thinking to take array, why you are thinking to take this data structure. Okay, what is the use of this data structure, why you have used this data structure to solve this question. They will ask such kind of question. Okay, so that's why time complexity play a very important role, because here you have seen you are doing the same thing in a very less time. You are making a transaction, right? Everyone, you do a transaction, and if your app is taking 10 seconds, you will not use that app. Okay, you will use that app that will take 1 or 2 seconds to do a transaction, right? So that's why there also we use a optimized solution. Okay, if you are creating an app, if you are doing some startup and you are saying hey, I will manage the transaction of vendor and this person, okay, and your app is taking 10 seconds to do a simple transaction, then nobody will use your app. You have to optimize your code, and for that time complexity play a very important role. Okay, okay, yes, lead code is good, but to go to the lead code part, first your basic should be clear. You should not go directly jump to the lead code part. Okay, so let's first tell me the this workshop. Okay, so here like we have discussed till the time complexity, but like we have only 1 hour. Okay, but there in the workshop we have 6 to 7 hours. There we will go deep into the time complexity, which data structure, why this data structure, and how to use that structure, data structure, what is space complexity, and like how to calculate time complexity in big often. That thing we will discuss in the DSA part, in the Java part. And apart from this, we will see the front end part, how to connect the front end part with the back end part. Okay, so this will be the 2 month workshop, guys. And I am like telling you ki please I'm requesting you ki please join this workshop. You will get to know about a lot of technology. Here you can see you will get to know about GitHub, data structure, Java, JavaScript, advanced Excel, okay, blockchain, which is a very trending technology here, data visualization using some tools here, responsive website you will make with the help of HTML, CSS. And again, like from the day 2 to day 5, I will say the same thing. Don't go to the rat race. Okay, don't be in the rat race. Don't try to take, like someone is saying ki, hey, please go to Python, you are going to the Python. Please go to Java, you are going to the Java, because Java is a good tech. Okay, no, first you have to explore each and every part. If you are starting from the beginning and you are saying ki, hey, I have to make a field, if I have to make a career in IT field, so first your motivation should be is what, you should give 1 month and explore each and every part. After that you should pick some tech, like Java, you can pick in the front back end, or Node.js, or you can pick in the front end the React.js framework. Okay, or you can go to some technology like blockchain, machine learning. Okay, depends on you, depends on the, okay, interest. Okay, but try to first explore each and every part. Don't try to listen to your friend and anyone. Okay, first try to explore each and every part, and after that try to make a decision. And after that, what you have to do, guys, you have to master that thing. Okay, if you are saying ki, hey, I will learn Java, so you have to be like very much efficient in the Java. If anyone is asking about Java, you should be clear about each and every concept. Okay, so everything is correct, every technology, from the testing, from the front end, from the back end, from technology, from the machine learning to the cloud computing, everything is perfect. The point is you should master one thing proper. Okay, it is not like 2 months you are giving in Java, after that someone is saying ki, hey, in Python there is a good career, there is a lot of scope in Python, and after that you switch to Python, so you are not learning Java also and you are switching to the Python, so you will be in a loop and you will be in the rat race. Okay, so there will be no improvement, and this is like my experience that I am telling you. So that's why you can take this course. It is about it is of 399, which is a very low price. Okay, and there you can get the live session first, you get the recording of the previous session, there will be the one-to-one doubt clearing session. Okay, in the live chat, sorry, in the live classroom, the Zoom classroom, there you can discuss about each and every doubt you have. Like here I can see the chat, and there is one way communication, right? you have a lot of doubt you are not able to express in this chat, but there we can discuss each and every doubt. And after that, if you are like want to learn something extra apart from the workshop, apart from the basics part and some mediocre part, and apart from like implementing practical implementation, then you can take this full stack program. And you have the great opportunity. We have a discount here that is 700 rupees off till 26 October. So this is our Diwali offer. So you can enroll in this full stack program. Here you will learn about data science, full stack, full stack program. That is your front end part and the back end part. In the front end part, you will go to like you will learn about the responsive website, how to create, how to connect your back end part with the front end part, how to call your API from the back end to the front end part, and you will create a lot of interesting projects. Apart from this, you will have the DSA module also, where you will see the how how to think of a particular problem, how to approach a particular problem. Like you are saying that I have to start with the lead code, right? But there is a proper way to start with the lead code. Okay, if you are saying hey, now like tomorrow I will jump to the lead code part, okay, then what will happen? For the first 5 days, for the first 10 days, you have motivation, you will like solve a 5 to 6 question by yourself or by seeing the solution. But after that you will lose the interest. Okay, you will lose the interest because you don't know about a lot of concept. Okay, you don't know about lot of concept, about lot of basic thing. Okay, first your basic should be clear. Okay, in order to create a building, your base should be clear. So first make a base, and in order to make a base, you have to do a structured learning. Okay, and this program is good here. Okay, I have also taken this program, so you can take, right? So this program is good, and like I will be the mentor there, and there are good mentors that are teaching in this program. You have a one-to-one mentorship session, and apart from this, if you have any doubt, we will clear the doubt in the live session. Still you have doubt, we will take the doubt session class where your doubt will be cleared. Okay, apart from that, the project, that is 15 project, and you will get the certificate. And if you have the right skill set, right knowledge, right path, then you will get the job. Okay, and here also we are providing the placement support. That is, after the learning you will get the company. Okay, you will get the interview call, and you have to just like we will take the mock interview also, and after that you have to just give the interview. And like yeah, this is all for this full stack program. And yeah, so guys, hope I'm able to clear most of the doubt of yours. And apart from this, yeah, how can we get the certificate, sir? Okay, one more thing, yeah. So how you can get the certificate here? So let me share the screen now. 1 minute, yeah. So okay, so from here, certificate, right? Here you have to sign in first, and after signing in, it is not working. Yeah. After signing in, here you can see the attendance. You have to mark your attendance. After after your attendance, what will happen? You will get the option to download certificate. See, my attendance is 71%, so I'm able to download the certificate. If the attendance is more than 50%, you will be able to download the certificate. Apart from this, join the message group, go to this portal, and from there you will get the information about the course. And here again 7,000 off, and if you will see our course, full stack course, is 36,000, and you will get the discount, and the course will be of 29,000. It is a very less price, and you will get the quality content. Okay, everyone. So this is all for today, guys. Thank you, everyone. Thank you for the session. Happy Diwali, everyone. Happy Diwali. Okay. Yeah. Be safe and enjoy your Diwali, and try to explore each and every part, right? Yeah. Thank you.
Hey, hi guys, this is Sai Kiran from LetsUpgrade, and I'm here today to congratulate you all guys for completing or like for pursuing our Essentials program in various fields what we do. And I want to tell that yes, this is amazing program what you're doing. But if you want to continue this learning and want to take your career to next level with a one-on-one personal mentorship, what we are not providing in Essentials, and also build real-time projects, then join our 6 months PGP full stack program in data science or AI/ML or web development in MERN stack or Python Django. That's it. Bye-bye.